We've talked about integers and decimals. When you have a decimal number, all the digits to the right of the decimal represent a part of a whole number. This part of a whole number can also be shown using fractions.
Boy, do I know about fractions. I fell off a jungle gym when I was 5, and I fractioned my arm, like right here, and then...
Section A, fraction terms.
A fraction is made up of two parts.
The top number of a fraction is the numerator, and the bottom number is called the denominator. In the fraction 3/7, or 3 over 7, the 3 is the numerator, and the 7 is the denominator.
The numerator represents the part present, while the denominator represents the whole.
So, the numerator is what you still got, and the denominator is what you originally had before I took it from you.
Sort of. Think of a pizza.
Oh, yeah, pizza. No cheese, though.
What kind of a bonehead doesn't like cheese on his pizza?
I just don't like cheese, Klaus.
Okay, you've got a pizza with all 6 slices there. So the part and the whole are the same. That means the value of the fraction is 1 because the numerator and the denominator are the same. You can divide the numerator, 6, by the denominator, 6, to get 1. Fractions can have larger numerators than denominators too. If you've got 9 slices, then you've got more than one whole pizza. When this happens, the value of the fraction is greater than 1 because the part present is greater than the whole. You've got more slices than there are in a whole pizza. And there's cheese on this one.
Listen closely to this one. Closer. Closer. Sometimes fractions can have different numbers but identical values.
Look at the fractions 2/6, 3/9, and 4/12. They're actually all equal to one another. Fractions are kind of wacky, but this will make sense. If we look at these fractions using a pie chart, then they would all represent the same fraction of the pie. Each of these fractions can be reduced to the fraction 1/3.
How do you know you can reduce a fraction? Well, you can reduce a fraction when the numerator and denominator have common factors, like the 3 fractions we just mentioned. So what's a factor, you ask?
A factor is a vital term to have tucked away in your memory bank. A factor of a number is any number that can be multiplied by another number to get the original number.
I like it! Sounds confusing!
Actually, it's not hard at all.
Think of the number 6. Since 2 times 3 equals 6, the 2 and 3 are factors of 6. Likewise, 1 times 6 is 6, so 1 and 6 are also factors of 6. Thus, the factors of 6 are 1, 2, 3, and 6.
So to find the factors of a particular number, you just want to find 2 numbers you can multiply together to get that number. Now, let's return to our fractions and try to reduce them.
We'll start by reducing 2/6. Notice that both the numerator and denominator of this fraction have a common factor, 2. If we divide 2 into the numerator, 2, we get 1. Then we divide 2 into the denominator, 6, to get 3. So the fraction is 1/3.
The value of the fraction hasn't changed. It's just been reduced. The value remains the same because both the numerator and denominator have been reduced by the same number, 2.
The same is true for 3/9 and 4/12. If we divide the numerator and denominator of the first fraction by 3, then the fraction is 1/3. And if we divide the numerator and denominator of the second fraction by 4, then we get 1/3. So 2/6, 3/9, and 4/12 are all equal. Pretty freaky, these fractions, eh? Remember, you reduce a fraction by finding a common factor between the numerator and the denominator. Then you just divide the top and the bottom of the fraction by their common factor.
Now that we've talked about the basics of fractions, let's put these puppies together and take them apart.
Section B, adding and subtracting fractions.
So, Now we're going to add and subtract some fractions. But before we do, we got to check the denominators. We got to take one important step if the denominators or the bottom numbers of the fractions are different. We'll look at fractions with common denominators first.
Okay, so let's say one pot of coffee has 6 equal cups of coffee in it. Okay, now I'll drink 2. What fraction of my original 6 cups of coffee is left now? I don't know. Somebody tell me, please.
Before we can figure out what fraction is left, we must first figure out how much he drank. He started with 6 cups of coffee, and those 6 cups made up the whole, or 1 pot of coffee. So the fraction for that is 6/6, or 6 cups of coffee out of 6. The amount of cups present were the same as the whole.
Each cup equals 1 cup of the whole, or represents 1/6 of the total amount of coffee he began with. So if he drank 2 cups, then we combine them by adding 1/6 and 1/6. Notice that both denominators are 6. That makes things easy.
When we have the same denominators like we do here, we just add the numerators together. We'll get to problems with different denominators in a second, so you'll just have to hold your horses.
To add these fractions with common denominators, just add the numerators and leave the denominator alone. He can be a little bit grumpy at times. 1/6 plus 1/6 equals 2/6. 2/6 have been drunk. Or, if we reduce this fraction by dividing each part of the fraction by 2, 1/3 of the pot of coffee is gone.
Well, how much is left then?
To figure out how much is left, we need to subtract what has been taken from what was originally there. So we subtract what was taken, 2/6, or 2 cups of coffee, from the whole 6/6, which represents the original 6 cups of coffee.
Just like the addition of fractions with common denominators, we subtract fractions with common denominators by subtracting the numerators while leaving the denominator. So we subtract the numerators. 6 minus 2 equals 4. We leave the denominator, so our answer is 4/6. We could reduce this fraction further by dividing the 4 and 6 by their common factor, 2. Dividing each number by 2 leaves us with a numerator of 2 and a denominator of 3. So after 2 cups have been drank, 2/3 of the original 6 cups of coffee still remain.
Now, if the denominators in fractions being added or subtracted are different, then we've got to alter them so that they have common denominators. Before we get to that, we've got some more terms for you.
We've already looked a little bit at factors. Looking at the factors of a number will determine if the number is prime or composite. A prime number is any number whose only factors are 1 and itself, such as 7. We can multiply 1 times 7 to get 7, but that's it. There's lots of prime numbers. 7, as well as 5, 3, 11, and 23, and 29, and 31.
There's also 37, 43, and, 17 and 19, 53.
The second type of number is a composite number. This is any number that has more factors than just 1 and itself. 6 is a composite number. 6 and 1 are factors of 6. 2 and 3 are also factors of 6, since we can multiply 3 times 2 to get 6.
Don't forget, a prime number's only factors are 1 and itself. A composite number does have factors other than 1 and itself.
Now that you got factors underneath your belt, we'll look at fractions that don't have common denominators.
In order to add or subtract fractions without common denominators, we must find the lowest common denominator for both fractions. We want to make our denominators as low as possible. If the denominators in your problem are prime, then the lowest common denominator is simply the first denominator times the second.
Why is this? It's because both numbers are as low as they can get. And what you're looking for is the lowest number that both these numbers are factors of. So the lowest common denominator of 3 and 5, both prime numbers, is 15. 3 and 5 are both factors of 15.
All right, we've got one more thing to throw at you.
The lowest common denominator is also 1 times the other. When all the denominators are composite and do not have any common factors other than 1, like 8 and 9.
Both 8 and 9 are composite numbers. 8 has factors of 1, 2, 4, and 8. 1 times 8 is 8, and 2 times 4 is 8. So each of these numbers can be multiplied by another to get 8. 9 has factors of 1, 3, and 9. But 8 and 9 don't have any common factors besides 1.
So since 8 and 9 are composite and do not have any common factors other than 1, we find the lowest common denominator by multiplying them together. The lowest common denominator then is 72, or 8 times 9.
Coming soon, the denominator. He's been sent from the future to save the past. He's part man, part machine, all fractions whiz.
What do you want?
The denominator is 72.
That's right. How did you know that?
I am the denominator. I was sent here from the future to help you with your fractions.
Thank you. Thank you.
Scratch my back.
The denominator. Coming soon.
Sometimes you have denominators that are both composite and have common factors other than 1. Remember, a composite number has factors besides 1 in itself. When this is the case, the lowest common denominator is found by finding the smallest number that both denominators have as factors. Let's say you want to find the common denominator for 4 and 10. We'll start with the larger of the two numbers, in this case, 10.
I'm bigger.
Yup.
First, we find multiples of 10. That simply means we're multiplying another number by 10. We're looking for the lowest common denominator possible, so we'll multiply 10 by small numbers first. We start by multiplying 10 times 1. Then we multiply 10 times 2, 10 times 3, and so on, until we find a number that has both 10 and 4 as factors of it.
The first multiple of 10 is 10 times 1, which equals 10. But 4 is not a factor of 10. There's no way to multiply 4 times another whole number to get 10. So we go to the next multiple. 10 times 2 is 20. And from our multiplication tables, we know that 4 is a factor of 20, because 4 times 5 equals 20. So both 4 and 10 are factors of 20.
Remember, you're always looking for the lowest number that each denominator is a factor of. 20 can be divided by both 4 and 10. 20 divided by 4 is 5, and 20 divided by 10 equals 2. 20 is the lowest common denominator for 4 and 10.
Look at these multiples of 10. Notice that if we continue to find multiples of 10, that 40 is also divisible by 4 and 10. But 20 is lower, and you want to keep things as simple as possible in math.
Sure, if you like to do things the easy way.
We're trying to make the denominators in our fractions the same, but we can't just switch the numbers and go on. We have to multiply the numerator and denominator of each fraction times a number that will make both fractions have the same denominator. Now let's put all this stuff to use and add a couple of fractions.
We'll add these two fractions, 7/12 and 5/18. The first step is to find the lowest common denominator.
We can't add fractions unless the denominators are the same. Both 12 and 18 are composite numbers, so we can look for the lowest common denominator by finding the smallest number that has both 12 and 18 as its factors.
We again start with the larger number, 18. We'll find multiples of 18. 1 times 18 is 18. 12 isn't a factor of 18. We can't multiply 12 by any whole number to get 18, so we keep going. 18 times 2 equals 36. 12 is a factor of 36 because 12 times 3 equals 36.
So, the smallest number that has both 12 and 18 as factors of it is 36. 12 times 3 equals 36, and 18 times 2 equals 36.
Now that we know the common denominator is 36, we can multiply both parts of each of the fractions to make their denominators the same. Remember,
As long as we multiply the numerator and denominator of a fraction by the same number, the value of the fraction doesn't change.
yes. That enables us to make the denominators of both fractions the same without altering the value of the fractions.
Pretty nifty.
I'm impressed.
It doesn't change.
Let's start with 7/12. 3 times 12 equals 36. We also have to multiply the numerator, 7, by 3. That way, the value of the fraction doesn't change. 7 times 3 is 21. So our first fraction is now 21 over 36. Now the other fraction. The denominator is 18. We multiply 18 by 2 to get 36. We multiply the numerator by 2 also to equal 10 for our numerator. So our fraction is now 10 over 36.
Now both of our denominators are the same. We haven't changed the value of either fraction, just altered them so the denominators are the same.
Let's say I like to eat pie, but I can't eat a whole one. So I eat a half, a fourth, or an eighth. And those are all fractions. Those are all fractions. Those are all fractions. Those are all fractions. Those are all fractions.
Okay, we've got common denominators for our fractions. So now that our denominators are the same, we can add or subtract the fractions and then simplify if possible.
We add 21/36 and 10/36. When adding or subtracting fractions, we add or subtract the numerators and always leave the denominator the same. 10 and 21 equal 31, so our answer is 31/36. 31 and 36 have no common factors, so we can't reduce it any further. Our answer is in its simplest form.
We won't do it now, but subtracting fractions is done in the same way as adding.
Remember, when you want to find the lowest common denominator of fractions with different denominators, there are 3 possible scenarios. First, if both denominators are the prime, then just multiply them together. The second possibility is if your denominators are composite, but they have no common factors other than 1. In this instance, you also multiply the denominators together. The third possibility is if the denominators are both composite and have factors other than 1. When this happens, you find the lowest number possible that both denominators are factors of. Then multiply both parts of each fraction so that your denominators are the same. Section C, multiplying and dividing fractions. Multiplying fractions is easier than adding or subtracting them because you don't need to worry about having a common denominator. To multiply fractions, you multiply the numerators together, resulting in your product's numerator, and then you multiply your denominators together, resulting in your product's denominator.
I don't like it. It's too easy.
So let's say you want to multiply 4/3 times 5/8. You multiply the numerators, 4 times 5, to get 20 for your product's numerator. Then you multiply the denominators, 3 times 8, to equal 24 for your answer's denominator. So your answer is 20 over 24.
This fraction can be reduced.
Both numbers in the fraction are divisible by 4. 20 divided by 4 equals 5, and 24 divided by 4 is 6. So our simplified product then is 5/6.
That's it for multiplying fractions. Remember, multiplication saves time and effort.
Mathos. Every year, Mathos engineers work to make life easier for families in America. For years, people have had to add again and again, but through the wonderful new development of multiplication, the average citizen can find totals much easier than ever before. By helping to save time and effort, Mathos is bringing America closer to defeating the communist threat. A Mathos product can be found in every American home.
Now, we'll look at dividing fractions. Remember, we said that division is the reverse of multiplication.
For example, we want to divide 8/3 by 4/6.
Instead of trying to figure out how many times 4/6 goes into 8/3, we use the fact that division is the inverse of multiplication in order to find the answer.
So instead of dividing by 4/6, we flip it to make it 6/4. 6/4 is known as the reciprocal of 4/6.
The reciprocal of a fraction is simply the fraction flipped over. The reciprocal of 8/10 is 10/8.
Hey, so if I stand on my head, does that mean I'm the reciprocal of myself?
Very funny.
Now let's go back to our example.
We flipped the fraction 4/6 to make it 6/4. After flipping one fraction, we just multiply the two fractions like we did before. We multiply 8/3 times 6/4 in the same way we did earlier. We multiply the numerators, 8 and 6, to get 48, and the denominators, 3 and 4, to get 12. Our fraction is 48/12.
We need to take one more step in this problem.
48/12 can be reduced because both numbers are divisible by 12. So we divide 48 by 12 to get 4, and then divide 12 into 12 to get 1. Our answer is 4/1, or just 4. Why just 4? Because 4 divided by 1 is 4. So the answer to 8/3 divided by 4/6 is 4.
Remember, to multiply fractions, you multiply the numerators together, then the denominators together. Then you reduce the fraction if possible. To divide fractions, you first have to flip one fraction over to find the reciprocal. Then you just multiply the fractions and simplify your answer.
Section D, mixed numbers.
The final type of number that we'll discuss in this section on fractions is a mixed number.
A mixed number is any number that contains an integer and a fraction, like 3 and 1/6. Anytime you're working with mixed numbers, you first want to convert the mixed number to an improper fraction.
What's an improper fraction? Well, an improper fraction is one which has a larger numerator than denominator, so it's kind of top-heavy.
Next, we'll add a couple of mixed numbers, 3 and 1/6 and 2 and 1/3.
Our first step in this problem is to rewrite 3 and 1/6 and 2 and 1/3 to make them improper fractions.
We make them improper fractions because everyone loves a rebel who flouts the conventions of society.
Actually, it's because you need common denominators in order to add fractions, and you can't do that with mixed numbers. There are two ways to convert mixed numbers to improper fractions. Here's the first way.
You want to convert the 3 into an improper fraction that has the same denominator as the fraction. The 6 is the denominator, so we want to make our whole number 3, a fraction that has 6 as the denominator.
How do you do this? The best way is to multiply your whole number times the denominator in your fraction.
So you multiply 3, the whole number, times 6, the denominator. 6 times 3 equals 18. 18 is your numerator. 6 remains the denominator. You haven't changed the value of your fraction. 3 is the same thing as 18/6 because 6 can be divided into 18 3 times. Now you just add 18/6, your whole number, to 1/6, your fraction, to equal 19/6. 19/6 is the same value as 3 and 1/6. You got an improper fraction.
Now we'll do the other mixed number another way.
You multiply the whole number in your fraction times the denominator, then add the numerator. So for this mixed number, you multiply the whole number, 2, times the denominator, 3, which equals 6. Then you just add the numerator, 1, to equal 7. This is the numerator in your improper fraction. The denominator stays the same. So 2 and 1/3 equals 7/3.
Either way you convert the whole number, you're gonna get the same improper fraction.
We now add 19/6 plus 7/3. We add the fractions just like we have in the past.
We first find the lowest common denominator of 6 and 3. The factors of 6 are 1 times 6 and 2 times 3. Since 3 is the other denominator, and it's a factor of 6, we know that 6 is the denominator. So 19/6 stays the way it is, since it already has 6 as a denominator. To make 7/3 have a denominator of 6, we must multiply both the numerator and denominator by 2. That gives us a new fraction of 14/6.
Okay, everybody square dance. Now that the denominators are the same, we can add the two fractions.
Leaving the denominators the same, we can add the numerators 14 and 19, so the sum is 33/6. We're almost done. We can reduce this fraction because both numbers are divisible by 3. so we divide each number by 3 to get 11 over 2, or 11 halves.
We can either leave the fraction this way, or convert it back to a mixed number.
We convert it back to a mixed number by dividing the denominator into the numerator. So 11 divided by 2 is 5 with a remainder of 1. The remainder is the numerator of the new fraction with 5 as the whole number. The denominator stays the same. So 3 1/6 plus 2 1/3 equals 5 1/2.
That's it for fractions.
If you didn't catch it all the first time, go back and watch it again.
Quiz 4.